Welcome, everybody. I do believe, despite running late for my last class, we're on time. Hey, welcome. It's the start of a new semester, a new year even. And look at all of you, so fresh faced and uncrushed. No, you don't definitely have doom and gloom in your front years. No, of course not. Who told you any of that? No, my name is Ross Tucker. I'm your instructor. I will be your instructor and stand-up comedian this year. So please hold your laughter and applause till the end. Let's say a couple of words about fun stuff, and then we'll actually get into content about this class. What you should know is this is Nimona, and I misplaced my. I like to have a little toy to throw around in class and demonstrate stuff, and of course I misplaced her. No. Okay. So you'll see her next time. This is Nimona, and she says this class is metal. Yeah. Wait, is this metal or is this metal? Which one is metal? I can't remember. Whatever. This class is metal. Even more so than Metallurgy 101. Okay, here are the most important points from the syllabus. At least I think what you should probably all pay the most attention to. I'm not going to read the whole syllabus. I hated it when instructors would read at me on the first day of class. We're not going to do that here. Here are the things you should know. Office hours, 10:45 to 11:45, Monday, Wednesday. Yeah, it's a weird time. I'm sorry. I rather overbook myself too much. That's why the time is weird. Please note, despite the fact that I just said I overbooked myself, I will overbook myself further. If these times don't work for you, ask and ye shall receive. I am happy to help if these times don't work for you. But also don't wait until 1 week before finals to start asking, you know. That doesn't help you as much as you think it does. And I also here then too. There are only room for about 5 people in my office, and I do like to have group things, but that means only the top 5 people are going to be able to fit in there. So please, if you want to be in the top 5 of the class, you should come to office hours. Now let's see how many people want to be in the top 5 of the class. Okay. So, actually, there are 2 sections, so the top 2.5 people out of this class. Oh, that's disgusting. No. Maybe we'll fit 6 in the classroom so that nobody has to be cut in half. Slides are posted in Canvas for each class. They're posted based on the class number. This is slide set 01. I mean, it's the last thing posted in the files slides section. If you're looking afterwards for which class was on which day, that'll be a little annoying. I will try to post a calendar so that you can look up, what topic did we cover in what class and what slide set. The biggest point is though, do not, for the love of God, do not take notes by writing down verbatim everything you see on the screen. Download the previous slides and annotate them. Do take notes though. I will say a lot of things. I do not just expect you to read based on the slides and not come to class. 30% of your class grade is participation. Are you here? Are you engaging? Are you listening? Are you thinking? Are you talking? Do, by all means, annotate those notes and slides. Do not just rely on, I'll read it after class. I don't need to pay attention. Homework and quizzes, we start immediately. Homework is due every Saturday except for breaks. Quizzes are every Friday except for if there's a midterm or final or during a break or whatever. The homework is on masteringphysics.com. The instructions in the syllabus are, I was told in the morning class, in the 3 o'clock class, not working. So I will get back to you ASAP. I want you guys to start on this immediately. I will be here late tonight until it starts working for you guys. If anyone is willing to stick around and help me troubleshoot after class, that would actually be particularly useful because I can't see what it looks like on the student end, which is why my instructions were wrong. The quizzes are on Canvas, and I just want to say a brief word about these. They're very easy to cheat on, and if you do so, you're an idiot. You know why? Because these are the questions for the final and the midterm. If you want to know how you're going to do on the final and the midterm, try the questions from the online, honestly, and then you'll see yes, I'm on track, no, I'm off track. If you learn from your mistakes, the quiz percentages for your final grade, 5% with all questions. If you just blindly cheat on the Google, on the Canvas quizzes, yes, you'll get a free 5%, and then I promise you will bomb the midterm and the final, and you will have to retake the class. It is a very easy and seductive thing to think, oh my God, it's not proctored. You can just, wait, what's not AI? It's, what's the freaking cheating website now? It's SmartNotes or that's not it. Whatever. You know, there are websites where you can download the answers for. That's not going to help you when you're in class taking the midterms and the final on paper. So please be honest. And if you do this, if you learn from your mistakes, you will do much better on the final and the midterms. And your grade will go up and you will be happy. Likewise with the homework. I will look at the end of the semester. This is the last I'm going to say that is preaching here. Last time I'm going to say that's preaching. At the end of the semester, I do have some discretion to round grades up. I don't round grades down, but I do have discretion to round grades up. And I will look and I will see if people have 100% average on their quizzes, and then the same questions on their final and their midterms they got 45% on. Well, I'm sorry, I'm not going to be very sympathetic. No matter how much you ask me, please, I need to get into med school. No, I can tell you were cheating. If your homework average grade is 104%, you got every single extra credit point every single time. No, I'm not dumb. I'm dumb about some things, but not about that. Make your mistakes on the homework, make your mistakes on the quizzes, learn from your mistakes, and you'll do better on the finals. Then I'm more likely to be sympathetic at the end of the semester. Not that anyone in here has ever thought about cheating on anything ever once. Midterm and final are in class. I should say midterms and final are in class. Those times are posted immediately. Oh, God. A couple words now. That's a little bit about the class, a little bit about me and the other fun things. Hopefully not a fun thing. I go by Dr. Tucker. I use male pronouns. I've been at ASU for forever. I got my bachelor's here, my master's here, my PhD here, my job here. I will probably die here. Probably be buried in the crypt underground where all of the vampiric professors are buried. I will be undead here. Actually, maybe I am undead. Maybe that's why this job feels so long. Anyway, moving along. I've been teaching since 2012. Oh my God, 12 years already. Full-time since 2016 here on campus. And ASU West is a lovely place. I love Passion. They do pay me to say that. Okay, and now, please, may I give the stage to Ms. Alex Boyd.
Hi, I'm Alex. I will be the SI leader this session, or this semester, sorry. We will have sessions Tuesday, Wednesday, Thursdays from 6 to 7. Tuesdays and Thursdays will be in person. All 3 days will be have access to Zoom. So our first session will be tomorrow. This is the first time ever having an SI leader for physics, so I am super excited. This is also my first time being an SI leader. So I am learning this role. I do know physics though. So if you have any questions, feel free to ask them. If I'm not able to answer them right away, I will get you an answer as soon as possible. Yes.
So for those sessions, are they like different material each time? Or is it like the same thing?
It will depend on the content that we go over in class. I'm unable to be in class for this this time frame, but I will be attending his 3 o'clock class, so I will be up to date on the material that you guys are going over. So it really just depends on how much content he goes over and where I see some struggling is going on. I will also have a Google form that I will post tomorrow with my session, that if you have any questions, you're more than welcome to send them over there. And then if I have an overwhelming amount, I will add those to a session, or I will add like links to different websites that you can go through to maybe go through some of the questions.
I strongly recommend you listen to this woman. She knows what she's talking about. And also small group instruction. Like, she could make big money doing this professionally. She's here making little money doing this for all of y'all. This is a big thing to be taking this on for an SI. What I'm trying to say is this is a very valuable opportunity, and I strongly encourage that you take advantage of it. Seize the opportunity. Thank you. Likewise, office hours. Use me. Use her. Use each other. Form study groups. Oh, dang it. I forgot to post. I put together a Discord channel, Discord server that I encourage people to use, and I forgot to advertise it to the 3 o'clock section.
I think Rachel did. A little bit.
Good.
So,
Good. Well, I need to send the link out at any rate. Could I volunteer you? If you don't see me send the link out tonight, will you poke me? Will you email me? Thank you. Awesome. Okay, now another little thing that is near and dear to my heart. I'm going to take about 3 minutes to extol the virtues of something that my 111 students in the past have, many, not all, but many students have enjoyed. This is an unofficial club on campus, and yeah, should I be plugging a club? Yeah, the thing is, sorry, not sorry. Even though this is a club, the content with what I teach you in particular next semester, the 112 content that we're supposed to get through for med students to prepare for MCAT, really overlies with the science that you could learn from here. So maybe I should sell this as this is a club, or maybe I should sell this as free, extra free tutoring in a fun environment. I don't know. I should think about how I want to sell this better. Maybe I should charge the university for me to run this. No, I don't. This is free, and this is fun. Do you like hiking? I don't know if you've noticed, but it's pretty outside. Do you like camping? I don't know what your generation says, something like touch grass. Is that a thing? Go touch grass. We can literally touch grass. Not in the valley. You have to go a little bit north. We go a little bit north. Get out of the city. Touch grass. Do you like technology? If so, you're a nerd. Hey, I'm a nerd too. Can nerd out. I'll teach you how to build circuits from scratch. There is a club, informal club here called Snark, where you can go outside, see Arizona, have an adventure, get some exercise with a view, learn emergency preparedness skills, build your resume, and some circuits all at once. How to join? Sign up on the Google form. That reminds me, I need to get you all into the Google form. Right, we'll do that next. There's a Google form I'll have you fill out if you are interested. I'm doing an info session tomorrow, which is to say Tuesday at 10 a.m. at the normal meetings. Well, the normal meetings on campus are not required. If you can't make 1:30 Mondays, that's fine. It's more the events that we do out and about that are the real meat of the club. Anyway, oh, Alex, you had to go, right? Yeah. Oh, let me hold you. Bye, Alex. Okay. So that's the end of the about the class, about me. Here's a club that you should consider. Let me get you all onto the Google form now. Everyone go to Canvas. Take a device and go to Canvas. Under the syllabus tab on our Canvas, there is a link called the Jujul participation form. Pretty sure it's Jujul anyway. Click here. Log in with your ASU email, or actually, I can't remember if I make you use your ASU email. The most important thing is that you always use the same email. If you use different accounts, you may or may not get all your participation points. This is how I track participation. This is also how I take quick surveys and do other stuff. But for your participation grade in Canvas, for your 30% of the class grade, you need to be participating, you need to be entering stuff in here. A brief note about that, by the way, if you get a question wrong in class, you automatically fail the class. Just kidding. It's okay. I don't look at correctness. What I look for is, are you making a good faith attempt? If I see somebody enter 0, 0, 0, 0 for every question, I'll know that you're trying to game the system, and I'll give you 0 for that day. You put 0, I'll give you 0. If I see somebody making a lot of wrong answers, that's perfectly fine. They'll get 100% if they're making a good faith attempt and missing it. If you don't know how to do something that I'm asking, you can either try, or if you don't even know how to start, ask me a question. They're short response forms, not just numerical entry. So you can type, here's where I'm stuck, Tucker, and I'll see it on my computer over here, and I'll answer your question. That way, if you're too nervous to raise your hand and shout out in front of the whole class a question, then you can ask me discreetly in private, and I probably won't say your name. Yeah. Okay. By the way, If you are so bold as to raise your hand in class, that is also very good. I strongly encourage it. Raising your hand and shouting questions out are strongly encouraged in this class. But many people I've found prefer the anonymity of asking a question in the Google form. Has everyone managed to find the Google form? That's plenty of time to stall. Okay. Question A is always the same. What is the name you would like me to call you? If I call on you for a question, what is the name that I should call? Just your first name is just fine. If you were a Sam, there might be more than one of you, so maybe Sam last name. If you're Jose, too, you're often a couple of Jose's. Jose and the last initial is fine. You don't need to tell me your entire name. In general. Question B is what I was just selling you on here. If you want to find out more about this and are available tomorrow at Tuesday at 10 a.m., yes is question B. Or no is the case may be, but you don't need to type no. I won't not contact you unless you don't put no. I will only contact you if you put yes. Yeah.
So if we're interested, but we're not available tomorrow, do we just?
If you are interested but can't make it, sure, you can type that. You can type that and I'll contact you separately.
What?
You could type a message to me.
Okay.
Yeah. I mean, yeah, let's say that. You don't need to say no, I'm not interested. If you are available, type yes and I'll make sure to email you. If you're interested but not available, then say that and I won't bug you tomorrow at 10, but we'll figure something else out. Good. Okay. Okay, so any questions about the class, me, setup, syllabus BS that we usually spend the entire first week doing in college? Yeah.
So I think I got the book access stuff, but it's bringing up like the payment stuff.
No, don't pay. You've already paid. ASU does it university-wide.
Okay.
So don't pay twice. There should be a tab, which is apparently I didn't make it show. There should be a tab where you can get an access code.
Yes. Okay.
And that needs to plug into another tab, a special place. But the first class said that wasn't working correctly, and I do want to get into topics. So I think, as I said before, if anyone's willing to stay after and help me debug it, great. If not, I will really try my hardest to get answers to you about textbook, etc. access immediately. Could I pester you again if I don't also remind everybody about OpenStax by the end of the day? Would you also tell me to remind everyone about OpenStax? OpenStax. There's a free online textbook which is really high quality. I really enjoy it. It's an excellent, not accessory, an excellent supplementary text that I want to plug people into. It's free. So yeah. But let's unless there are any other questions, let's dive into content. Yeah. I really would like to get into some material. Okay, there's a little bit of terminology, and then a whole lot of applying simple ideas in ever more complicated problems. So here's a little bit of terminology. First off, kinematics is the subject of this first month of class. Kinema comes from Greek meaning movement, I think. I'm told. I don't speak Greek. So kinematics is the science of motion, the study of movement. You can remember kinema means movement because this is the root word of cinema. Who's seen motion pictures at the cinema? Hey, see, it's all connected. Later on, we'll talk about kinetic energy, motion energy, all the same thing. Okay, so the science of kinematics can be summarized in one line. Where something is can be described as a mathematical function. That's it. Everything else is math. So the location of an object can be represented by a vector function of time. That's the entire hypothesis of the science of kinematics. Everything else isn't really physics. It's not experiment. It's not experimentally proven. It is not something which is hypothesized, tested, and evolves into theory status. What we're really doing is we're studying math for the next month. We're just talking about it in physicsy words. if you've ever taken brief calc, you'll recognize a heck of a bunch of the things that we talk about are actually just those topics in disguise. Okay. But, even if you have taken Calc 5, don't fall asleep. We do interesting things that you may not have known before. Terminology here, vector. When I said a vector function of time, what I mean is a vector in general is something which requires both magnitude and a direction to it. A vector is a quantity which is not just one number. It has to have multiple numbers to specify it. For instance, I am 2 meters away from you right now. I am 2 meters in the x direction and 0 meters in the y direction. First thing I said was a distance. That's a scalar. That is a single number. I am 2 meters away from you. 2 meters away, a distance. That does not have a directionality associated with it. Then I am at position coordinates 2, 0, 2 meters in the, I think I said 0, 2, 2 meters in the y direction, 0 meters in the x direction. The second example that I gave, that's a position, that's a vector. That is a, I need to specify which direction, which way. You could also say, I am 3 meters and 45 degrees, 45 degrees left in front of you. I'm specifying 3 meters, a distance, and also an angle. Which way do you need to face in order to face me? So that's a vector, something that has both an amount and a which way, and which way can be specified by giving multiple x, y, z coordinates or a heading like 45 degrees left of straight, whatever. Vectors are usually written either in bold, and you'll see in textbooks, or on my slides, I can't actually render in bold for reasons. So in my slides, I will usually try to remember to put arrows on the top when I'm talking about a vector quantity. Another tip, whether it's a vector. We're going to spend a long time, 3 weeks, dealing with vectors in one dimension. That is to say, only along a single axis of motion. We don't have x, y, z coordinates if we're just talking about along the x-axis. What we'll see makes a vector in one dimension is if a minus sign applies. So, am I moving leftward? My displacement is negative. Am I moving rightward? My displacement is positive. I can move 2 meters, and I can move 2 meters. The difference between those two kinds of motion is in one of them, my displacement is negative. That's showing I'm moving leftward. One of them, my displacement is positive. I'm moving rightward. That's a vector quantity. It makes a difference whether it's positive or negative. I'm often talking about a vector. Scalar. Every vector has a scalar as part of it. Scalar is just the amount, the number. The scalar associated with a displacement is the distance. The example I just gave, 2 meters, negative 2 meters. The magnitude of both of those displacements was a distance. I moved 2 meters in either case. If you can always just specify something completely with a single number, you're talking about a scalar. For instance, the temperature in here is 300 kelvins-ish. Actually, there are a lot of people in here. 310 kelvins. It's more, right? Does it ever make sense to say the coordinates of a temperature? No. No, there is no such thing as temperature upwards, temperature eastwards. Temperature is a scalar. Time. What time is it? How long of a time did it take for something to happen? Do you ever say northeastward seconds? No. Time is another example of a scalar. Mass is another amount of a scalar. So vector, magnitude, and direction. Scalar, just magnitude. Here are 2 vectors in a scalar. Position. Oh, I already gave an example of this. Give an x and a y coordinate where something is located, that's a position. We usually refer to this as x vector. Position, x vector. Displacement is where have I gone? Not where am I. Position tells you where you are. Displacement tells you where you've gone. I have displaced 3 meters leftward, -3 meters. I have displaced 4 meters rightward. I just moved a displacement of +4 meters. Displacement is the difference in two positions. Note, differences can be negative. Does that make sense? If I go from x = 5 to x = 4, how far have I gone? -1 meter. Yeah, from 5 to 4 is -1 difference. 5 minus initial, 4 minus 5 is -1. So that's a vector. It makes sense that there's a difference between negative and positive. The distance, if I go from 5 to 4, what is the distance I have gone? 1 meter. Yeah. So distance is the magnitude of the displacement. Later, we will talk about more than just a single direction, more than just a single plus or minus. We'll talk about x-axes and y-axes, and for one brief but glorious second, and z-axes. We'll have to use the Pythagorean theorem to find the total distance along a path. That'll come later. We won't do that right now. Okay, now let me build up to an idea here, one thing at a time. Distance divided by time interval. What am I describing? Speed. Distance divided by time is miles per hour. This is what your car's speedometer tells you. Or if you've got a map and you can see, all right, how far did I go? How long did it take me to get there? That ratio is the miles per hour. I actually described two different quantities just now. What my car speedometer tells me changes as I speed up, slow down, coast. Whereas if I take a final point and an initial point and divide by the time taken, that is a single number. No, they're both scalars. Distance is a scalar, divided by time still stays scalar. The difference is one I'm talking about average, one I'm talking about instantaneous. If you have a finite displacement, which distance, and a finite amount of time, how many miles did I go? I drove 180 miles. How long did I drive them? 3 hours. What am I talking about? Over a 3-hour interval of time, I sped up and slowed down a bunch of times. If I'm just telling you, I went 180 miles, it took me 3 hours, what have you just learned? That's an average speed. I'm telling you enough to let you calculate one value. We can also talk about what your speedometer shows, the instantaneous speed. Instantaneous speed is what your speedometer reads. What your speedometer tells you is, if you keep going at this rate, how far will you go in a mile? Again, your speedometer tells you if you kept driving steadily as you are, this is how far you would go in a mile. The speed calculated based on a short time interval. How far would you go if you stayed steady? Yes? As it turns out, average speed and instantaneous speed are both not really the physixiest ways to deal with things. As it turns out, the scalar quantity distance will be harder to calculate with once you get used to things. Distance is a special case, the magnitude of a more general quantity displacement. Usually I want to talk not about distance divided by time, but displacement divided by time. That quantity is velocity. If I let velocity go positive or negative, if I let velocity have a direction, velocity is the vector rate of change. This symbol here is something you may not have seen. If you have seen it, don't spoil it for your neighbors. I'm going to define this in a particular way. When I say d divided by dt, what I mean is this is the slope of an x versus t graph. If I graph position versus time, this combination of symbols means tell me the slope of that. Now I can calculate a slope over a wide range looking at an initial and a final, and calculating the rise over the run, or I can look at, well, how tilted is the graph at this point, and that tilt can change, yeah? We'll practice this in a second. Yeah? Okay, so whether we're talking about average or instantaneous, velocity can have an average or instantaneous form, but it is always the slope of position versus time. So can slope go negative? Can slope go negative? Can you ever have a slope downward? Of course you can. It's a vector. Velocity is a vector. Once we get into multiple dimensions, I'm going to stop telling you what we're going to do because that'll be in a couple of weeks. So I said we're going to focus on 1D for a while. For now, velocity is absolutely negative. Has your car's speedometer ever gone below 0, by the way? Mine has, but that's because it's a piece of junk that really needs to go to the shop. But speedometer tells you speed. What would you need to do a velocityometer? Does anybody's car read velocity? No. Velocities would also require a sense of are you going forward or backward relative to some origin. That's not something that your car is going to know which way it's headed. Theoretically, you could have something which reads positive or negative depending on the direction of motion, but I want you to know that when I'm talking about speedometer, that is in particular an absolute value that always is a single sign. It's always speedometers always say positive. That's for a reason. That's speed. Velocity is more general. Okay, now I've been talking too much. Let's do some examples. Question A, what is your name? Question B in the Google form, are you interested in more information tomorrow? Here, turn to your neighbor and discuss, and then put your answers in C. Where's it go?
It gives you the second. You could convert that if you wanted to. It doesn't specify what. Do you want it in seconds or minutes?
Default to seconds. If you stated in different units than I expected, but your answers were just like correct, you'll still get full points. But default to seconds. Oh my God, I didn't train you guys yet. Okay, sorry. Hold on a second. Every time you get an answer for something, hit submit. Do not hit submit another response. Always click edit your response. So again, once you get an answer or have a question, every time hit submit response. That means I can see your questions and answers as we go. But don't hit submit a new response or my spreadsheet with these answers gets 50,000 rows. I don't like that. For me to give you participation points if I have to. Anyway, so always edit response every time. And if you can't edit response, tell me that. I'll fix the form so you can. Yeah.
So we shouldn't wait to the end.
No, don't wait till the end. Also, if your browser crashes, that's bad. David, don't get confused. We're on C, not B. Okay, I want to emphasize the thing. No. One more minute. I want to give everyone a chance. But chop. Quick like a bunny. Okay, time's up. Couple of things. One, what's a kilo? 1,000. Does everyone know that? What's a centa? 100th. What's a milli? 1,000. What's a micro? Million. Okay. Learn these. I will assume that you know these four. I don't want to spend a class module on these, but you must know these four. Kilo, centa, milli, and micro. That is what I will put on tests, quizzes. If I put something that's not in this list of four, if I ask you what a mega something is, you can ask. If I put a pico thing on it, then I'll give you a free point. Next semester, I'll give you four more and say you need to learn these on your own. Okay? Yeah. Micro. Micro, but this is the Greek letter mu because we already have something. Starts with an M. And again, 1,000, 100, 1,000, million. These are the only four that I'll require you to do on your own. I might give you something that's not on this list, but then I would tell you along with the question. So what's 5 kilometers? 5,000 meters. Distance equals 5,000 meters. Speed, 20 meters per second. So time is clearly 25 thousandths, right? No, sorry, 20 times 5,000. What? No, what? What do? Do I divide? Do I multiply? Do I take the sine of one and then multiply by the exponential of the other? What do? Why? Huh? But how come dividing 5,000 by 20 gives me the number of seconds? Huh? Every second you are going 20 meters. So if I break 5,000 into pieces of 20 meters per second, I will get the number of seconds that takes. Okay, that works. Here's another way to make sure you don't get this backwards, because it won't always be this straightforward. We're going to get more and more complicated, more and more sophisticated, more and more profound in physics. Sometimes you won't be able to conceptualize it that easy. I always suggest the following. Write down the darn equation. For instance, we are talking about speed equals distance divided by time here. Write down the darn equation. Then fill in the blanks with what you know. What do I know? I know V. I know delta X. I don't know T. Now I've got an algebraic equation. 20 equals 5,000 divided by unknown. How do I get unknown out of here? Algebra! How do I algebra when I've got an unknown denominator? Can anyone tell me what to do? Multiply T over. So I get 20T equals 5,000 then? Divide by 20. So 5,000 20ths equals T. Yes, I strongly suggest you always start with a foundational equation. If you screw up, I or your classmate can catch you, or for that matter, you can catch yourself. If you just write down numbers on a piece of paper, you, your classmate, or I won't know what they mean. Start with the equation, fill in the blanks, algebra. Always. Okay. Correct answer is 250 seconds. 250 seconds, 4 minutes and change. Does it matter? No. You answer, if I don't specify, if you answer with any reasonable thing, I'll say that's correct. However, what you can expect is default to meters, seconds, kilograms, and combinations thereof. Call this the MKS system, meters kilogram second system. Every quantity I think that we'll deal with in this entire semester is some combination of meters, kilograms, and seconds. Default to those. That's what I'll expect to see, even though I would give you a point for things that are answered in non-standard units. I would also have to convert it to slow class down. Next, a little harder. Why aren't you talking? You should talk more. Talk. Talk to your classmates. And this will be question D. Yeah, I'll put it up here. Exercise D. Yes, starting from the same place, driving the same direction. Very good. Your attention to detail will serve you well.
Yeah, that would be easy. It'd be making it those numbers into decimals. Yeah. So just 66. So 3,600, 7,200.
Anyway. When I put a box letter up here like this, that tells you which one to put it into, if you forgot. Who's stuck? No one's stuck? Okay, I'll come around and give a hint.
Yeah, how you say it? Especially the key type thing. Or key. Yeah. It's definitely
So what does that tell you? Supposed to do it instead of looking
All right. That's more answers than the first section. Okay, so this is looking all right. Here's how I would tackle this. How fast is the car going? How fast is the car going with respect to what? Car's going 20 meters per second over the ground. How far is the car going compared to the truck? 2 meters per second. Think about it. If they start at the same place, where are they at time 0? After 1 second, where's the car? Where's the truck? How far are they? So after 1 second, they're 2 meters apart. After 2 seconds, where's the car? 40. Where's the truck? 36. The truck's 18 plus 18, right? After 2 seconds. So how far is the car from the truck? After 2 seconds, they're 4 meters apart. Every second that goes by, the gap increases by 2 meters. Right? How many seconds is in 2 hours? 2 times 60 times 60? 7,200? Yeah? Good. 7,200 seconds times 2 meters per second relative is 14,400 meters. 14,400 meters. Okay, that's the smooth way to do this. Velocities, it's not just moving at 20 meters per second. You could say, how fast is it moving compared to what? You can get a relative motion here. That's not the only way to do this. We can also say, where is the car? The car can be described as a simple function, velocity of car times time. Where is the truck? The position of the truck can be described by a simple function of time. Speed times time is distance. Speed times time is distance. Well, I know the position, I know the velocity of the car, 20 meters per second. I know the time interval. Are you guys all comfortable with me jumping to 7,200? Do you need me to show how to convert hours to seconds? Can I write 7,200 without fear? 7,200 seconds. Seconds cancel seconds. I end up at 144,000 meters. Now, if I look at the truck itself, 18 meters per second times takes the same time interval. 7,200 seconds is 7,200 seconds. Hey, what is that? Someone with a calculator. 120. Okay, so the step by step way to do it is to say, where is the car? It's gone 144 kilometers. Where is the truck? It's gone 130 kilometers. How far are they from each other? 14 kilometers, 14,000 meters. Okay. Note, is the first way righter than the second way? Pick whatever way makes sense to you. I will, from time to time, show you more than one way to do a thing. Pick a way that makes sense to you. I'm not going to require you to do things. No, I will not require you to do things in a particular way on tests and quizzes and homeworks. If you have a way that makes more sense to you, as long as that way is not freaking Chegg, you're allowed to use it. And I was like, no, I'm not even going to preach the second time. The change in the change of positions is 14,000 meters. By the way, does everyone know what this means? Do you know scientific notation? 1.4 times how many zeros do I shift it by? Yeah? You comfortable with this? I can use this for free without spending time on it? Okay. If you struggle with scientific notation, SI prefixes, or unit conversions, like turning hours into seconds, you're always welcome to ask, but I don't have planned to spend time in class unless you ask. So if you're stuck, by all means ask, but I'm going to move on unless people do pause me. Any last questions before we move on to the next bit? Let's talk about some graphs. Graphs are an incredibly powerful tool. They're also very sadly, very undertaught, at least in the Arizona public education system. My students very frequently struggle with graphs. Okay, maybe it's been a couple of years since you've taken algebra, but still. We're going to use them a lot, so let's practice. Let's talk about them. Here's a position time graph. Vertical axis position, horizontal axis time. Still got you for 20 more minutes. Don't lose your brains. Don't fall asleep. Okay? Right? We stopped at 45, right? Yeah. Okay, so I've got your brains for 20 more minutes. Stay away from me. Turn to each other. This will be question E. E. Position versus time. Question E. When is the object moving with greatest speed? Look carefully, me hearties. At what labeled time or times?
It should be slow.
Answer.
iClickers in this course.
I have tried iClicker, I've tried Google Forms. iClickers, I can't see everyone's response at once. Wait, who asked? You asked. I can't see everyone's response at once. I tried iClickers for a whole year and I couldn't get it to do as much as this. The one thing that screws up with the Google Forms occasionally is that sometimes people's connections get screwed with it. Worse than iClickers. If your connection gets screwed up, write it down on paper and you'll get full credit. But yeah. I should remember to tell you that.
1 point.
1 point or multiple points, but I'm talking about at an instant, not over an average, not over a range. It is not from A to B, from C to D. I'm talking about at instant A, at instant B. Hey, by the way, she asked a really good important question though. iClickers versus Google Forms. The only thing that I've found that Google Forms does occasionally do wrong is sometimes it glitches out and doesn't submit right. What I do is, if you don't submit 100% of your answers, just kidding. No, I don't require that you get every single answer in. If you are doing a majority of the questions, either asking a question or making a reasonable attempt, you get full credit. It's not, I don't do 70%, 80%, it's 100% to 0. Right? So, if you are submitting response along the way, submit response, submit response, submit response, if your computer glitches out over the last question, it's fine. If your computer is glitching out, if you don't have a computer, if something goes wrong at the beginning, write your answers on paper, hand them to me at the end, you'll get full credit. Yeah. So that should cover, I think, all of the problems. Google Form, I prefer the Google Form because it allows me to see everybody at a glance. iClickers just do that. Not that I can figure it out anyway. Okay, so who wants another minute to argue? Okay, 1 more minute to argue, then put your answers in or ask me a question. Yeah.
I'm gonna call it the y-axis, but it looks like an X. I'm assuming that's position based, like in reference to the point of origin.
Okay, ready? D. Now, there's a trick here. How do you tell the difference between C and D? Oh my God, that looks really, really close. Here's how to tell the difference. Here's why D is actually the correcter answer, the better answer. Look for curvature all the way from A until D. You don't have straight line segments. This is a cup. This is cupping, cuppitude. ABC cup is cupping down until D. At D, the directionality of the cuppage, the cuppification, the cuppitude, starts cupping up. It's an up cup, not a down cup. If you are cupping, you are not going at constant velocity. You have some acceleration. Your slope is changing. As long as the cup is downward, a downward slope is getting downer. So this slope at C is gentler, this slope at D is steeper. Look for that, look for that. We will have varying slopes from time to time in these examples. You look for not just what does it look like roughly, but look carefully. Is this steep? Is this steeper? How do you know curvature? That can get you some. That can be a trick for seeing things. Now I want to make a follow-up question here. If you goofed and thought C was the same as D, okay. I'm not actually going to put a test question that relies on you being able to see the subtle of a difference. I'm not that mean. Well, maybe I am, but in different ways. Okay. Here's the follow-up question that I want to know. When is the greatest velocity? There is a greater velocity than that. No. No. A. Velocity is what? How do you see velocity on a position graph? There's only a single positive slope here. Note, there is a difference. Greatest magnitude, D. Greatest value, A. Tell me this. Riddle me this, Batman. Which is a bigger number, -2 or -1? Who thinks -2 is a bigger number? Who thinks -1 is a bigger? Oh, come on, vote. Does everyone think that -1 is a bigger number? Everyone?
Depends on your perspective.
Okay, so my perspective is mathematical. Does it make sense to write -2? Whoopsie. Does it make sense to write with a pen? -2 is less than -1, or does it make sense to write -2 is greater than -1? Which of these is a mathematically true statement? The first one. -2 is left on the number line. It is a smaller number. Is smaller meaning greater or less magnitude? The magnitude of -2 is greater than the magnitude of -1, the absolute value. The absolute value of the slope is the speed. It is going faster at D, but it has a greater velocity because this is the only time velocity is positive. The greatest velocity is at A. Do you see this, the distinction I'm making? This is probably the single trickiest thing in this first 2 weeks, is being able to smell the difference between a greater magnitude and a greater value. -5 is a smaller number than 2. It has a greater absolute value, right? The absolute value of -5 is 5. 5 is bigger than 2. -5 is, damn it, it is left on a number line. It is a smaller value. -5 is less than 2. Yeah? All right. Watch out for this. This distinction is big. Come back to this again and again. So, are you comfortable with? Do you want to ask me a follow-up question for why the velocity at A is positive? You want to ask me a follow-up question for why the velocity at D is negative? You accept that the velocity at A is greater, even though the speed is less. You smell the beat I'm stepping in? You dance into this beat? Yeah. Okay. F. You get an F. I mean, no. You don't get an F. Answer. I get an F. Answer in F. Turn to your neighbor and discuss. The
It's not one of those that push down.
Yeah.
Because F is constant, B is also constant. Draw a tangent line to each, like how we have it.
Sorry? I think. Crap, I think the office is there. Go to the left.
So if it means, when does it start moving in the negative direction?
At what time or times is it moving in the negative direction?
So can there be more than one?
So I think just because
Ooh, a lot of this
starts
right here.
down, it's even.
I will say that something is moving in the negative direction if his position slope is negative. At what time or times, at what labeled point or points, does the graph have a negative velocity, a negative slope? Okay, so slope at A. Positive. You're going up. Position is increasing as time increases, yeah? Which direction is it moving at B? It's not moving. It's not moving at B. The slope is horizontal. It is at rest at that instant. For the slope to be horizontal means, come on, let me draw a horizontal line. For the slope to be horizontal, come on. For the slope to be horizontal means if you stayed moving like this, how far would you get? I am at 3 meters, I am at 3 meters, I am at 3 meters, I am at 3 meters. I'm not moving. B is a turnaround. B is not moving in the negative direction. B is not moving. F. What's happening at F? Same thing. Slope is horizontal and staying horizontal, moreover. What about a D? Shifting what? What about a C? What about an E? C, D, and E are all negative slopes. C, D, and E all have negative velocities. C, D, and E are all moving in the negative direction. Please note there is a difference between saying C's position is positive. C's position is positive. His x coordinate is, I don't know, 3. His x coordinate, his coordinate along the x-axis, this axis, the vertical axis, is greater than 0. C's value is positive. C's slope is negative. Do you see the distinction? E has a negative position. E also has a negative velocity, yes? So the position at E is negative. The position is getting negativer. It also has a negative velocity. Yeah? Am I breaking anyone's brains yet? I know it's a lot on the first day. Give me 3 more minutes, then I'll let you go a few minutes early, okay? Because it is a lot on the first day. When is the object speeding up? He said, slowing down. Here's question G. At what time or times, don't tell me a range, when is speed increasing? Talk to each other. Go on.
Well, you have to make sure it's over time. Because it wouldn't be D, right? Because that's a constant speed. So what would it be the case? D is a constant speed. It's not like you have to speed up.
Hint. Speed is the magnitude of the slope. To say something is speeding up means that the slope is steepening. At what instance is the slope going from less to more steep? But then you move forward. Make your predictions. I'll tell you the answer in a second.
Do we have to cover every question or just a bit?
Every. Did every time.
I didn't know that.
Yeah, again, for everyone. Every single answer gets a bit. Then go back to edit your response. To submit the next one. That way I can see everyone's responses as it comes up. Don't wait till the end. Don't be sorry. You can apologize if you're still asking that question the day before finals. Ready? Are you ready for the answer? Do you want to know the way? Am I moving fast or slow? At this instant. Okay, so fast, slowish, whatever. Am I moving faster or slower? Am I speeding up or am I slowing down? A is not the answer. He's slowing down. I am slowing down. At B, I stop, turn around, and then start speeding up. The turnaround point. Am I speeding up when I'm turning around? I was slowing down. I'm about to speed up. At that instant, I would say I am neither speeding up nor slowing down. And going from slowing down, about to start speeding up, that is neither. This is an inflection point. So at B, it is turning around. It is not speeding up at B. C, what is happening to my slope? We said D is the steepest slope, right? The speediest that it gets. The negativest velocity. So what is happening at C? Speeding up. What did I say about the curvature changing at point D? I was increasing my negative slope. I'm now about to start decreasing my negative slope. What is happening at D? Tell me about the speed at D. Speed is at a maximum. Speed is not constant. If speed were constant, then the slope would be a straight line. I see curvature, I see curvature. So this is where it hits the max speed. The max speed is not where it is speeding up. It speeds up as it increases a max speed. This is the max speed, then you take your foot off the gas pedal. What is happening next? Slows down. What happens next? Slows down still further. At D, it is at max speed. It is not speeding up. That's as fast as it gets. E, it is slowing down. F, it is stopped and staying stopped. So the correct answer for this is C and only C. If you are missing some of these, okay. Thinking hard about the meaning of slope and the magnitude of slope and the sign of a quantity and the way that a quantity is changing is the entire point of doing these exercises. I do not expect you to be getting 100% of this. Okay, there's one last thing I wish to tell you, and that is that I love each and every one of you. You are all awesome people. Go home, get out of here. You are all great. Unless you want to stick around and help me debug Brightwave. Yeah, we'll stay? Awesome.